Greeting everyone, today we from UKM would like to introduce our project on microbial flocculant for water and wastewater treatment. Everyone, it's a sad scenario, but also a reality we have to digest to this day, that our raw water sources are mostly polluted. We can't consume it directly as it contains numerous pollutants such as bacteria, plankton, decaying plant materials and others in form of colloidal particles. These water sources need to be treated properly before being distributed for human usage, and one of the favorable water treatment is flocculation. In general, flocculation is one of water clarification process to separate suspended solids in water by addition of some flocculating agent. In this process, colloidal particles existed in water will undergo destabilization process that will result in formation of larger particle that we called as floc. Floc with heavier overall molecular weight will suspend to the bottom of containers with the help of natural forces of gravity. Hence in this case, separation of the sediments can be easily done by collecting it in the bottom. As overall, the main objective of this treatment is to remove turbidity, suspended solids, color and dissolved metals. Now, let us move to the agent of this treatment that we called as flocculant. It can be in the form of organic or inorganic. Chemical flocculants is synthetically produced and reported to possess hazardous compound that might integrate into treated water and causing health problem to human, and also giving negative impact to the environment. And bioflocculant are extracted from natural resources, for example microorganisms such as bacteria and fungi, while can also be extracted from others such as plants. By saying so, bioflocculant is biodegradable and environmentally friendly, thus making its more favorable choices. Focusing on a solution that focuses on sustainability, we successfully found an alternative flocculants from natural resources, which are greener and more sustainable than conventional chemical coagulants. In this project, we discovered a newly found bioflocculant isolated from Langat River Selanger and was identified as Bacillus velezensis isolate JB7. The bioflocculant JB7 possesses mucus-like texture with rigid and compact structure. In terms of flocculation, JB7 show the highest and most excellent performance at 92.3% compared to others isolated bacteria. And after numerous of trials, we have successfully identified that JB7 can perform the treatment at maximum capacity in its optimum condition at pH of 6, with 0.4% of volume per volume dosage and 5 minutes sedimentation time, which can be considered short. Now, let's have a look at how this experiment was conducted. The process starts with high-speed mixing at 200 rpm for 1 minute and followed by slow mixing at 40 rpm for 5 minutes. This process to allow the particle to interact and bond with each other. And, lastly, it was left for sedimentation process for 5 minutes. In that duration, flocks had been formed and sediment naturally to the bottom of beaker by gravitational forces. As you can see in this video, the water treated by bioflocculant JB7, which label as R, has been more cleaner than the control without bioflocculant, which label as C. Bioflocculant JB7 had also been tested for its efficiency in treating other wastewater, which are domestic, aquaculture, and coffee effluent. And it had been proven that this bioflocculant JB7 was able to treat this different types of wastewaters, especially in terms of turbidity removal. As can be seen, JB7 was most suitable to be used in river water treatment with high removal efficiency for all parameters of turbidity, color, and suspended solids. The advantages for flocculation process itself is a simple treatment, cost-effective, easy sediment, and indirectly improved water quality. Besides that, the bioflocculant produce is an environmentally friendly, low toxicity, biodegradable agent and can be obtained at low cost. This research supported SDG. To specifically categorized, this research directly supported 4 of the goals, which SDG 3, 6, 9, 10. JB7 is suitable for commercialization since it offered advantages as listed below. First, it was produced from local source that is biodegradable and non-toxic toward humans and environment. Second, it had high flocculating activity and high removal efficiency towards suspended solids, turbidity, and color. Third, it also had shorter sedimentation time at 5 minutes, obtained high removal percentage above 90% of pollutants. Lastly, the sludges produced from the treatment are safer may used as soil conditioner or fertilizer additive. Thank you for your time and attention.